Good morning, students. In our physics class, today I am going to continue the lesson spectrum. In previous class, I have given introduction about the spectrum. Once again, what is spectrum? See, what is spectrum? A band of colors formed on screen when white light focus on a prism. The white light split into 7 colors. Whenever white light enters into prism, split into 7 colors and deviates in different places, differently, and that emerging colors other side of the prism placed on screen at different places. The 7 colors are not placed on same place because of deviation is not same for all colors. Yesterday in yesterday's class, I told reason. What is the reason behind that? Now once again I repeat. See here, V is equal to well-known formula. V is equal to F lambda. V is equal to F lambda. Here velocity is equal to frequency into wavelength. This is the formula, familiar formula we know. Now we know that every color having their own wavelength. Every color in the white light is having their own wavelength, red to violet to red. Each color have their own wavelength. For example, already yesterday I told you, previous class I told you that violet wavelength of the violet color is 4000 angstroms and wavelength of the red color is 8000 angstroms. Similarly, you see, if you see that V is equal to F lambda, now when lambda and velocity both are direct proportion. Both are in a direct proportion. Now, when wavelength is increasing, velocity increases. Wavelength decreases, velocity decreases. So, when velocity is, by that what we can understand, each color have their own wavelength. Because of the own wavelength, the velocity is also different. So, because of difference in the velocity, when refraction is taking place through the prism, all colors deviates in different places and deviates in differently, and emerging light also placed at different places, and that is why we can get on screen at different places. So we can get different colors, 7 colors on the screen. That band of colors formed on a screen due to refraction is called spectrum. That spectrum, what we are able to see, that spectrum is called visible spectrum. What is spectrum? Visible spectrum. Visible spectrum means we can see that spectrum with our eyes. We can see that spectrum. That is called visible spectrum. Now next one, invisible spectrum. In the spectrum, we can see some part. Other than that part, there is another spectrum, another region also there, that we cannot see with our eyes. That is called invisible spectrum. Example, see here, when you see the spectrum, what we can see, that visible spectrum, that is between violet to red color. There are so many frequencies. For each color have their different in that frequency, in the light, different frequency and different wavelengths. But in that some part only we can see with our eyes. Some part we cannot see with our eyes. We cannot see. What we cannot see with our eyes is called invisible spectrum. See, look at here, spectrum beyond red color, red end is called. This is one kind of spectrum that we cannot see. That means again we can continue in this remaining next topic we can understand. Now see here, spectrum beyond red color, red extreme, red end. After red end, what is the spectrum? We cannot see. That we cannot see. And also before violet. What is the before violet? Violet end. See, violet end, before violet end, there is a spectrum we cannot see with our eyes. We can see only between violet and red. red. That spectrum is called visible spectrum. Beyond red color and beyond violet color, there is a spectrum, but we cannot see. That is called invisible spectrum. Now, if you see that in this table, here see it is given clearly about each wavelength of the color, each wavelength of the spectrum. In that spectrum, each wavelength is given, different radiations are given, different wavelengths. They are with different wavelengths. See, if you observe here, visible, visible. What is that visible? Violet to red. Here wavelength is 400 nanometer to 800 nanometer. In angstroms 4000 nanometer to 8000 nanometer. Sorry, in angstroms 4000 angstroms to 8000 angstroms. In nanometer 400 nanometer to 800. What is the angstroms? What is the nanometer? Here, if you see this here, these are the units of to find the length of small quantity of length, to measure the small quantity of length, wavelength, to measure the wavelength, we use the units angstroms and nanometer. Here what is angstrom? Angstrom is we are well known about a meter. In that meter, 10.10th part of 10 power 10th part of the meter is 1 angstrom. Meter, in 1 meter, 10 power 10th part is called angstrom. That much small quantity. That also you can say as 10 power minus 10. 10 power minus 10. Actually it is meter by 10 power 10. We also can write as 10 power minus 10. That much small part in the meter, 10 power 10th part of the meter is called angstrom. Wavelength is that much small quantity. So that is why small quantity, small length we can measure using by angstroms. Now next, under nanometers. Nanometer 10 angstroms equal to 1 nanometer. 10 angstroms equal to 1 nanometer. This is also small quantity of length. So in nanometers also we can measure, and also we can measure with the angstroms. Anywhere we can measure. Any units you can use to measure the wavelength. Either the angstroms or the nanometer. See here, come here. This wavelength 400 to 800 nanometers. 400 nanometers to 800 nanometers. Or 4000 angstroms to 8000 angstroms. That region, what we can see, is called visible spectrum. That radiation, what we are able to see, is called visible spectrum. Above visible means end, violet to red, above red. That radiation is called infrared. What that radiation is called? Infrared waves. Here see, this region, what is the region of wavelength? 800 to 10 power 6. 10 power 6, 800 nanometer to 10 power 6 nanometers. That region wavelength radiation is called infrared radiation. That radiation is called infrared radiation. This part we cannot see with our eyes. Okay, next. 10 power 6 to 10 power 10 nanometers. That is, this range is called microwaves. This range is called microwaves. Now next, next above 10 power 10 nanometers, the total, whatever that may, more than 10 power 10 nanometers wavelength more than 10 power 10 nanometers is called radio waves. It's called radio. See, this above all, that region is called radio, belongs to radio waves. Now comes to back. Now here this violet to red, above red, infrared, and that is 800 to 10 power 6 nanometers, 10 power 6 above, 10 power 6 nanometers above, we can call as microwaves, and 10 up to 10 power 10 nanometers, above 10 power 10 nanometers, we can call this as that radiation is called radio waves. Now if we come back below 400, that means below violet, the wavelength below violet up to 10 to 400, that means 400 to 10, below 400 to 10, that radiation is called ultraviolet rays. Now these ultraviolet rays, this also we cannot see with our eyes. This is also invisible spectrum. Now below this wavelength 10 nanometers to 10 power minus 2, that means nanometer by 100, 1 nanometer by 100th part of nanometer, or we can say 10 power minus 2 up to 10 nanometers. That range is called X-rays. That range of radiation is called X-rays. Below 10 power 10, that means nanometer, in the nanometer 10 100th part, that is called 10 power minus 2. Below 10 power minus 2 nanometers, the wavelength below 10 power minus 2 wavelength, that range is called, the total remaining all range is called gamma rays. So this is the way we can write the we can classify the total spectrum in different with the different wavelengths and different radiations. Here see, first once again, here visible, that is 400 to 800 nanometers, that is violet to red. Above red, infrared, that is 800 to 10 power 6. Above 10 power 6 nanometers to 10 power 10 nanometers, microwaves, and 10 power 10 nanometers to above all, we can call them as radio waves. If you compare, and below violet, 400 to 10, below 400 to 10, that is called ultraviolet rays. And next 10 to 10 power minus 2, that means nanometer by 10th part, 100th part, nanometer by 100th part, that means 10 power minus 2. This nanometer, this range is called X-rays. And below this rays, below this nano wavelength, the rays are called gamma rays. Okay, such a way we can spectrum, we can divide into, we can classify into different ways. This total range is called electromagnetic spectrum. This total range is called electromagnetic spectrum. Here in electromagnetic spectrum, what are the waves are present here? Gamma rays, X-rays, ultraviolet rays, visible rays, infrared rays, and microwaves, and radio waves. This total range is called electromagnetic spectrum. Okay. Now, he also every wave having its frequency. Every rays have, every color and every rays have their own frequency. The frequency also we can divide here down. Frequency, and above we can say we can divide wavelength, and down below we can divide them into frequency. Here frequency means what? Number of waves happen for 1 second. Number of waves occur for 1 second is called frequency. You know well, we all know about that frequency. Number of waves occurs for 1 second. That is different for different waves, different rays. Now here radio waves, above radio waves 3 into 10 power 7 Hz. That is units are Hz. And now here up to 10 power 6. 10 power 6 up to 10 power 6, 3 into 10 power. See, this is called microwaves. Microwaves frequency is 3 into 10 power 11 to 3 into 10 power 7. Above 3 into 10 power 7 frequency, that is called radio waves. This frequency, below this, between this frequency, microwaves. And here 3.75 into 10 power 14 to 3 into 10 power 11. This frequency range is called infrared. And visible spectrum 7.5 into 10 power 14 to 3.75 into 10 power 14. This range is called, this range of frequency is called visible spectrum. And ultraviolet rays 3 into 10 power 16 to 7.5 into 10 power 14. This frequency is called, between this frequency is called ultraviolet rays. And 3 into 10 power 19 to 3 into 10 power 16. This range is called X-rays. And below this frequency is called, here we can classify all the rays based on wavelength and also frequency. You can see this is there, this structure is given in your textbook. Once we go to textbook, then you can understand. Okay, this is about electromagnetic spectrum. That's all for today. Thank you.